Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today we are going to learn about Young's double slit experiment. This is the lecture 2 of wave optics series and let's see what we can find out. This is the interference topic which we are dealing with. Now let's see. Suppose we have a source and just in front of the source we are putting a screen like this, say it is a black screen or a opaque screen, and then we are cutting two slits here. These two slits I am considering it as, say this is S1 and this is S2, and in front of that I am putting a screen. Now just observe the waveform, the wavelet. From S there will be these wavelets will come. These are primary wavelets, and these primary wavelets from S1 and S2, these are not sources, these are the virtual sources. These will actually form secondary wavelets. These are the source formed by wave S1 and these are formed by S2. Now these will interfere and produce fringe pattern on the fringe patterns. I'll tell you what is fringe pattern. Fringe pattern on the screen. So just understand one thing, this S1 is emitting some wavelets, this S2 also. Now these two are becoming coherent sources. Why? I told you in the last lecture that what is coherent sources. Coherent sources are those which are not having any, the phase difference between them will be constant. That will not be a function of time. Now let's look at here. This is S1 and this is S2. If they were of different individual sources, then I would have said that the phase difference between these two, they may not, this phi may be not independent of time. Not independent of time. But since I was having a common source and due to these are the secondary wavelets of this common source from the primary wavelets, I can say that this is actually independent of time. That means we are creating a coherent source using two secondary sources, that is by the slits. That is why the name of the experiment is Young's double slit experiment, YDSE. Now let's deal with the mathematical aspect of this topic. That is, see here, I am assuming that this is my screen and this is my, these are my two sources, the slits. This is S1, this is S2. The central line I am considering like this. This is the central line. Now I am putting a screen here, and here what I am doing here is that, let's say I am taking a point P on the screen, and S1 and S2, these are the rays, the waves. These waves are meeting at P and the resultant I will find out. Now I have to find out that they are meeting here. The resultant is constructive or destructive. That is, it is the maxima will form here or minima will form. I have already told you a little bit about constructive interference and destructive interference. When cos phi is equal to 1, the resultant intensity will be maximum, that is constructive interference. I'll tell you later. Now just see one here also, what is constructive and destructive. Suppose this is one wave and suppose this is the other wave. Now if I add them up, they are in phase. Then cos phi is either 0 degree or 2 pi, 0 radian or 2 pi or 4 pi, like that. Then they will simply get added up like this. This is exactly what is meant by constructive interference. And destructive means when they are out of phase. Okay, now let's see here. Let me take this as d by 2. That is the distance between the slits is d. So individually it is d by 2. let this be D, capital D. This is capital D. This is P. So this S1P I can write. This S1P I can write, that is, and say this one is X from the center. So this is this part, and this part I can write x1 minus d by 2, so x minus d by 2, and this I can write x plus d by 2. This is x minus d by 2 and this is x plus d by 2. Now what is S1P? This red length, that is x plus d by 2, x minus d by 2 whole square plus d square. What is this one? This will be, if I can extend it, this triangle, x plus d by 2 whole square plus d square, small d. Now we have got S1P and S2P. Now let me try to, what is the path difference? Path difference del x, that is S2P minus S1P, that is the path difference. Okay, now to find S2P minus S1P, we will do something here. Just see, S2P square minus S1P square, what will be that? That will be x plus d by 2 whole square plus d square. This is my S2P minus x minus d by 2 whole square plus d square. This is my total. Here also total one. Now d and d square will cancel. It will be 4x into d by 2, that is 2xd. Okay. Now this S1P and S2P, this square I can write S1P plus S2P, S2P plus S1P, S2P minus S1P, that is equal to this. See, S1P almost equal to S2P, that is almost equal to D, because I'll tell you, the length, when we are subtracting, if we are subtracting almost same quantities, but that subtraction will be something significance, but when you are adding them, that is almost equal. So I'm taking the approximation as D, that is the distance. So it was like this, the diagram was like this, and it was D. So I'm taking just D because this angle is very small. This theta dash, these are very small. So effectively it will be approximated. Now what I can write here, D, and S2P minus S1P is del x, that is 2xd. D into del x is 2xd. Now what I can write here is that 2 into D, because S1P is D, S2P is D, so it will be 2 into D. So I can write here del x is equal to x into d by capital D. This is the formula for my path difference. Two lights are having path difference this. That means S2P is covering say this much distance. If I take this is S1, this is S2, it is covering this much distance more, and that distance is given by this path difference. Okay, if these two are equal, then this S2P will be having some more distance. Okay. Now I will relate path difference with the phase difference. How to relate? Del phi will be, I have already derived this in the previous lecture, 2 pi by lambda into del x. Now what is 2 pi by lambda? 2 pi by lambda into, I can write x into d by d. Now let me, okay, or we can do it directly also if we want to. Suppose we want to find out the constructive interference, the condition for constructive interference. For constructive interference, we have already derived that del x should be equal to 2n into lambda by 2, that is even multiples of lambda by 2, half wavelength. Now we can write here x d by d is equal to 2n into lambda by 2, that is this 2n into lambda by 2, implies that x of n, I am writing x as n because of this n, x subscript n, that is 2n lambda by 2 d by capital D by small d. This is the distance from the center a bright fringe will occur. Because of the constructive interference, what will I get? I will get a bright fringe. Okay, and I will get some bright fringe and some dark fringes. Let me show you here. I will get it will be like this. There will be fringes. One fringe will be bright, other will not be bright, then again a bright fringe, then again dark, alternating bright and dark fringes. At the center, what we will get? We will get a bright fringe. You put n is equal to 0 and we will get a bright fringe, because both are actually converging. Both path difference will be equal, so we will get a bright fringe. Let's say this is x is equal to 0. So say this is the first, second, third. This is the third bright fringe. So this is, let's say this is the nth bright fringe. Nth fringe, bright, B-R-I-G-H-T. So this is xn. I think this much is clear. Now, what did we get about? And remember one thing, although this appears to be straight line, but these are actually hyperbolic. In a very small screen, this will appear straight line, but actually what happens, this fringe pattern is hyperbolic. It will appear something like this. We are not deriving that, but actually this is true. We are only seeing this much portion, or a very small portion, smaller than that. Now, this is, I am getting it as, say, del x, or I got xn. Xn is equal to 2n lambda by 2 d by d. Now, distance between two consecutive bright fringe, that is my, let's say, x of n plus 1 minus xn. What will it be? This is, let me show you, say, n lambda d by d for simplicity. I can write it here as n plus 1 lambda d by d minus n lambda d by d. If I take common lambda d by d, I will be n plus 1 minus n will remain, n and n will cancel out, so I will get lambda into d by d, and that is called my beta, or that is my that I can call, that is fringe width. It is the fringe width. It is the distance between the consecutive bright fringes. Or okay, now let me show you about the dark fringes. The dark fringes, let me show. See the delta x, that was my difference, phase difference, that was path difference, that was x into small d by capital D. Now, this path difference for destructive interference or for minimum intensity, that is interference we have already discussed in the previous lecture. For destructive interference, this x d by d, that should be equal to 2n minus 1 lambda by 2, for n is equal to 1, 2, dot, 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 dot. It will go like that. So I can write x is equal to 2n minus 1 lambda by 2 d by d. This is xn. It is the nth dark fringe, we can say nth dark fringe. Now I've got my nth dark fringe, and the same diagram we can use to explain that. The central fringe is always a bright fringe. I've already discussed that. Let's say this is the central fringe. This is my second. This is my third. And this is the central line. This is my first dark fringe. This is my second dark fringe. And that I am finding the xn. I hope this is clear now. Now, let me show you what is the distance between consecutive dark fringes. What was xn? That will be xn plus 1 minus xn. What was xn? Xn was 2n minus 1. Let me write xn at first. 2n minus 1 lambda by 2. 2n minus 1 lambda by 2 capital D by small d. So what will be my, since it is lambda by 2 and capital D by small d will be common, and 2n minus 1, that will I can write 2 of n plus 1 minus 1. So lambda by 2 capital D by d, that I will be taking common. 2n plus 2 minus 1 minus 2n plus 1. 2n and 2n will cancel, plus 1 minus 1 cancelled, and this 2 and this 2 will cancel. So I am left with lambda d by d, that is same as the beta we obtained for the bright fringes case. So what are the formulae we learnt? The formulae for path difference, I am getting x into d by d, but d is the slit width. It is also called slit width, the width between the slits. Capital D is the distance. It is from the screen, distance from screen to slit. X is distance of concerned fringe, or the position on the screen. That can be bright or dark, anything. Okay, my next formula was for bright fringe. For bright fringe, xn was, for bright fringe xn was 2n into lambda by 2 d by d, and for dark fringe xn was 2n minus 1 lambda by 2 d by d. And now let us solve a numerical problem, then the concepts will be very clear. Now we have a question. This question states that in Young's double slit experiment, a light of wavelength, that is lambda, of 5460 Armstrong is used and slit width is given as 0.1 millimeter. Screen is placed at 2 meter distance from slit. Find angular position find angular position of 10th maxima and first minima. This is my question. So what are the given data? Lambda have been given, slit width they have been given, screen is placed at 2 meter distance, that is capital D, and we are asked to find the angular position of the 10th maxima and the first minima. Okay, let me explain this problem. Let me draw this graph. What do they mean by the angular position? Suppose I have the two slits here, and now I will be taking this distance. Let's say this is xn. If I have to find phi n, I will be taking from this point. This is phi n. Now see, this distance is d, and this distance also will be equal to d approximately, because this phi n is very small, because this is d and this is d. So I have already assumed at the starting that this d is less than capital D, small d is less than capital D. Now this is okay. Now for phi n, I can write phi n in radian, that is xn by d. So we have to find xn for both. That is my strategy. Now just understand one thing. For bright fringe, xn is 2n lambda by 2 d by d. What is n? N is 10. Let me cancel 2 and 2. N is 10 at bright fringe. Lambda is 5460 Armstrong, that is 10 to the power minus 10 meter. Let's convert everything into SI. D, what is D? That is 2 meter. What is small d? That is, I can say it is given 0.1 millimeter, so 0.1 into 10 to the power minus 3. After solving, I will get xn is equal to 0.1092 meter. Let me check the calculation once. So after calculating this xn, I am getting xn's value is 0.1092 meter. That is at 10.92 centimeter. Now, what is phi n? As I have already told you, phi n in this case will be xn by d, that is the distance. What is xn? 0.1092 meter divided by what is d? D is given as 2 meter. So we will get 0.0546 radian. If I convert it into angle degree, that is 0.50546 divided by pi into 180 degree, I will be getting the value. If you calculate, you will get 3 degree 7 minutes 37 seconds. I have calculated up to second. So this is my angular displacement of the 10th bright fringe. Now next is asked, find the angular displacement of the first dark fringe. So for dark fringe, what is my linear displacement or the distance? That is 2n minus 1 lambda by 2 d by d. What is 2n minus 1? 2n minus 1, that is first bright fringe. I will take n is equal to 0, then I will get 1 here. So just lambda by 2, here is 1, lambda by 2 I already know, that is 5460 into 10 to the power minus 10, this is Armstrong. 2 into d is 2 by 0.1 into 10 to the power minus 4. So the value of xn, that will be equal to 5, for this 2 and 2 will cancel out, and just the 5460 and the power of 10, 5460 into 10 to the power minus 6 meter. Now if I can find angular displacement phi n, that will be simply xn by d. So angular displacement will be 5460 into 10 to the power minus 6 by 2, and that will be equal to 0.00273 radian. 0.00273 radian, and that will be equal to, if I convert into degree, 0.156 degree. I can convert into minutes also, but I'm keeping it in decimals of degree, that is 0.156 degree. So that was all for today's lecture YDSC, that is Young's double slit experiment. In the next lecture, we'll be covering more topics under interference. Okay, thank you. And if you like my channel, then please subscribe to my channel and click on the bell icon. And you can join our Telegram group for doubt solving and mock test. Thank you.